What's up everyone? In today's video I'm going to show you how to solve this problem, which is on a Tesla interview for a mechanical design engineer position. So the problem states a force F of 10 newtons is applied to the direction indicated per meter depth into page. The 300 millimeter long triangular beam is aluminum 1100 series and extends 2 meters into the page. What is the moment about point A per meter of depth? The system is on Earth, at sea level, gravity acts in the direction of F. Note, the centroid of a triangle is located at h/3. So we're going to break this problem down into 4 steps. 1, draw a diagram. 2, we're going to gather our important information. 3, we're going to identify the relevant equations to solve this problem, and then identify and solve for our unknowns. And finally, we're going to review the problem statement and answer the question. So let's jump right in with number 1. We're going to start by drawing a diagram. As you can see, we're dealing with this solid beam which is connected to a wall at point A. So this is a statically indeterminate problem. There's not going to be any movement and all of the forces are going to be in equilibrium. So we're given we know our centroid is going to land at h/3, so we can calculate that based on our length of 300 millimeters divided by 3 is 100 millimeters. And we know that since this object has mass, that's where our weight force is going to act. So let's mark our weight force on the diagram, and then let's draw all of our forces. Now, because this is a fixed beam, we know that about point A, there's going to be a reaction force in the x and y directions, and there's going to be a moment about A. So you can see that all annotated on the diagram. Now, we don't know what our weight force is. We do know what the force on the end of the beam is. That's 10 newtons. Let's move on to step 2. Let's gather the important information to solve this problem. So we know this beam has mass, and we're given a clue that we are dealing with an aluminum 1100 series beam. So a quick Google search will reveal that the density of this beam is 2,710 kilograms per meter cubed. Meanwhile, the area of the triangle can also be calculated using 1/2 base times height. We know the dimensions, so we can easily find our area of the triangle to be 0.006 meters squared. Now, we're wondering what the moment about A is per meter depth. So let's calculate our weight per meter depth. Weight is equal to mass times gravity, but we need to divide out our length because we want to know the per meter depth. So that's our density times our area times gravity, which is going to leave us with mass times gravity over length, or a Newton per meter. So we calculate that to be 159.5 newtons per meter. Now we can move on to identifying the equations that we're going to use to solve this problem. We already know that this is a statically indeterminate problem, and therefore we can use our equilibrium equations. This means that because all of the forces are not causing an acceleration in any direction, the sum of the forces is going to equal 0. So we know this is true for the x direction, the y direction, and the sum of moments. Now, we want to know our moment about A, so let's do a quick sum of moments. We take the moment about A, which we assume to be counterclockwise and therefore positive, and we can use the right-hand rule to determine that the other forces are going to cause negative moments. So set this all equal to 0. Now we can solve for our moment about A, and we know that it's about 18.9 Newton meters. And remember, this is per meter of depth. So that's going to be Newton meters per meter, which is approximately 19 Newton meters per meter. We go back and review our problem statement. We're wondering what the moment about point A is, and that's going to be about 19 Newton meters per meter. So there you have it. That's how you solve this Tesla interview question. This was my first video, and I hope you enjoy.